Okay, so now we are ready to actually make a molecular dynamics simulation. Um, First, I'm just going to clean up our interface a little bit. So we don't need this slider anymore, so I'm going to delete that. And I'm also going to decrease the size of our world a little bit here so that we can see what's going on more easily. So now with these two atoms, I'm going to actually just do forward here 1.05. Now we can see these oscillations a little more clearly because we've just made the world smaller in relation to the atoms. Okay, so now what we're going to do is make this so that we can be using multiple atoms at once. And to do that, we're going to need to change this acceleration function a little bit. So right now, the way we've written this, each turtle is actually accelerating the other turtles. But we're going to change that so that it's going to still be the same basic math, but we want each turtle here to add up the forces from all the other turtles on itself and use that to accelerate. So just to show what that will look like, if we create a third turtle here, and let's ask turtle 1 to move forward, turtle 0 and turtle 1. So now we're going to get 3 turtles. And this might look like the right thing is happening, but it's actually not quite right. We're getting some somewhat weird behavior here. And the reason for that is over here, each turtle is asking all the other turtles to set their acceleration and their velocity based on the force just from itself. So this one is asking the other ones to set their acceleration and force just from the force they feel from this one, even though this one should really be accelerating based on the net force from both of these. And so we need to change this to take that into account. So the first thing we want to do is, change this. Instead of doing acceleration directly, we're going to do it based on force. And I'm going to actually initialize those out here. So I'm going to have a new force in the x direction. And actually, we can just call this fx, force in the x direction, because we don't need to keep track of that between time steps in each direction. And I'm going to move this for now outside of this function, outside of this, what we're asking the other turtles to do. And now I'm going to set this force in the x direction to be equal to whatever it already is, plus the force that we calculate here times dx. And then set the force in the y direction to be fy plus f times dy. And so now what this is doing is we're starting out with a force of 0, and then we're asking all the other turtles, so if I'm this one, I'm asking the other ones, update the force that I'm feeling in the x and the y direction based on the force that you're exerting on me here. And all the other turtles are going to do that, and they're going to add their force to the existing force each time. So at the end of this, fx and fy will be equal to the total force that this turtle is feeling from the other turtles. Then to accelerate over here, we don't need dx and dy here because we're already doing that here. All we need to do is divide by the mass, and we'll get our new acceleration and our new in both directions. And then here it's the same. Now we're going to set our velocity based on the new acceleration and the old acceleration, and the current velocity. And then we're going to update, again, in the y direction, update our velocity based on the current velocity, the old acceleration, and the new acceleration. And then after we do that, we'll update the accelerations that we're keeping track of to be these new ones so that they're updated next time. Okay, and we're going to get something. Oh, right. This should be fx and fy. Okay, so when we do this, we see these things start moving and then burst apart. And I tried making this video on the previous take, and I wasn't sure what's going on. And then I realized what's happening here is we need to get rid of this right turn 180. Because before we were asking the other turtles to calculate the force they were feeling. But now we're actually asking the other turtles, calculate the force you're exerting on me. And so we don't want to have this right turn 180. And if we get rid of that, now we'll get these 3 atoms interacting. In this case, they happen to set up basically in a line, and so they're staying in a line. but if we set up in other directions, we'll get other types of movements. Here they're in more of like a triangle configuration. So this is basically now our molecular dynamics simulation. We can add more atoms and they're going to do the same type of thing. There'll just be more of them and they'll all add the forces up like this. And that is the basics of molecular dynamics. And in the next video, I'll do one more thing, which is to show maybe more than one thing, but I'll show at least one more thing, which is how to have a temperature slider that affects the temperature and of the atoms in the system.